Hello.
Yes, sir.
Yeah, what we have discussed in the last class.
The data collection part completed in the first class, and measures of central tendency have been started.
Good, good, Sunita. Thank you. Yeah. Can you brief me what is primary data, secondary data? What is the useful of the central tendency?
So primary data is the fresh data. Secondary data is data which is already available. That is like second-hand data. And types of central tendency are mean, mode, median. And we have reached up to median parts here.
That's great. Wonderful. Yeah. Thank you, Sunita. That's good. Let me share my screen. Yes. Right. Primary data. Under that, we discussed different things and what are the sources of primary data. That means from primary data, how you will get the primary data we have seen, how will get the secondary data we have seen. And after that, we went to the measures of central tendency. In that, we have seen different the types of the measured tendency, that is arithmetic mean, geometric mean, arithmetic mean. Under that, median, mode are there. And we have seen what is the use of the mean value, right? Which will represent the whole value. The mean value is very important to represent the whole group. In that arithmetic mean, there are direct method and indirect method as well. When the types of data is changed, we have seen like what is the individual series. When individual series is given, how to calculate direct method and indirect method. And we have seen the examples. And after that, when is continuous series, how to calculate the direct method and indirect method. We have seen that. Another thing is like the third part, continuous series. When continuous series is there, and how to do the direct method and the indirect method. And after that, I think we entered into the median part, right? Properties of the median, arithmetic mean. Yeah, we have seen few things in that. And what is median here? Yes, merits and limitations of the arithmetic mean, it's there. But even those things, when we take the values in order to use that arithmetic mean also, in order to take the values, in order to declare the mean value, and this we required some other, we need to take the values so carefully. Otherwise, you can't tell by taking one value. And because as the mean value is the very important value in any calculations, when we are taking that value, when it is representing the whole group, it should be carefully taken. Now coming to the median, and it is the median is the value of the middle item of a series arranged in ascending order, descending order. We know that when we arrange the values in ascending and the descending order, the mid value, we consider it as a median value. And we know that, and it will divide into the two series parts, into two equal parts. Number of terms less than the median value and the number of terms more than the median value are equal. It is a positional average or measure. See this? It is a positional average or measure. Average is talking about the representing the things. When we take the mid value, when we have a continuous series, this is important. It should be in some kind of series. Otherwise, you can't tell that. Let us say, if you are taking the randomly the numbers, if you take the mid value in that, it's easy. It's very difficult to understand the other whole numbers. Now, for example, let us say arrange the data in the individual series. If you take this, you know this how to calculate this. If you want to take which one is the mid value, we need to know the position. This is first position, second position, third position, and we need to understand how many are there: 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 plus 1 divided by 2. Then 12 divided by 2 is 6. And the sixth value, sixth term is located as the median. And what is the sixth term here? 25th one. This is how we'll calculate the median, right? I think many of you know, right? Or should I need to repeat this? Median? Median is the mid value. Hello?
We got
yes,
it.
Sir, understood, sir.
Yeah, median is the mid value, because if you are coming from the non-mathematics background, and you may not catch it immediately, but till 10th, everybody studied this, right? I'm just assuming that you know at least this one. Okay, right? Median is the mid value. See, when there is odd numbers are there, 11 values are there, and n plus 1 divided by 2, you will get the mid value. Mid value here, see, n plus 1, there are 11 numbers. 11 positions or 11 sizes there. 11 plus 1, 12. 12 divided by 2, that is 12 divided by 2 is sixth one. Sixth term is the 25th. The median of this is this. Now, discrete series. When we have these kind of discrete series, the formula will be again, apply the formula size n plus 1 divided by 2, or the next higher to that. Now, look at the cumulative frequency column and how to calculate this, arrange the data in the assign. This is very important. Here also, this is important. Arrange the data whether in the ascending or descending order. You can't take directly this one. See this? There are different numbers are there. We don't know what kind of data it is, but different numbers are there. They went for the ascending order, small to big, right? Here also, first they need to arrange the numbers in an ascending order. So this is the frequency. Marks are arranged in the ascending order. Frequency, as per the frequency, they have calculated this. Now they have calculated the cumulative frequency, 60. Now n plus 1 divided by 2. What is n here? The frequency, 60. Plus 1 divided by 2, 61. 61 divided by 2, 30.5 item need to be located in the cumulative series. And here 13.5. Where is the 13.5 will come here? And here, see this? 13.5 is near to the 36. And the marks is 35. This is the thing. And if you understand the concept of this, here, when you know that this frequencies, let us say, how we will do numbers is, instead of this before series, individual series, this is individual values. This is in group values. Let us say the statistics class, quantitative class. There are students who got 5 marks. There are 10 students who got 5 marks. 7 students who got 10 marks. 2 students who got 15 marks. And let us say, in this way, the data is calculated. For that, you need to get this total of the frequency, the cumulative frequency, and then formula n plus 1 divided by 2, 30.5 item need to be located in the cumulative series. Here, you need to locate where it is this. This is near to the 36. And the frequency is 30, and the 35 is the median one. What is the continuous series? Again, we need to understand what is this. Again, we need to arrange in the ascending descending order. Cumulative frequencies need to be done. Value of the middle item by using the formula, that is n plus n divided by second the item. Okay, n divided by the 2. Right. Find the cumulative frequency which is equal to n divided by 2th or just higher to that value. Like let us say here, this is 30.5. Just higher to the value is where we got this 13 point. Yeah, 30th one located. Here we have seen this just higher the value. After 30.5, which one is the just higher? Sorry, no, 30.5. The near value is here. It is coming 36, right? The just higher
36, sir.
36. We don't have 31, we don't have 32, we don't have anything. That's there. Here also the same. Just a higher value to that value, corresponding class interval in which n-divided term is the lies in the identifier. Apply the formula L plus. L is the lower limit of the median class. These values are important. I is the magnitude of the median class interval. CF is the cumulative frequency of the class preceding the median class. Now, let's see the example, then you will understand that. Okay, frequency is done. Cumulative frequency is there. See the difference between this continuous series and the discrete series is that we know directly these things. See, for 5 marks exactly we know 10. For 10 marks, 7 people, 15 marks 2. But here it is giving in the continuous series is from 0 to 10. This is the frequency. In between 10 to 20, this is the thing. When number is changing, when type of data is changing, definitely we need to calculate in a different way by using those formulas. Okay, this is the frequency and this is the cumulative frequency is 180. Now n plus 2th item, 180 divided by 2 is 90th item located in the cumulative frequency, 90th item. What should we take? 98th item, near to the 98th item. Higher, near. 105, right? 105. 105 item.
105.
Yeah, 105. 105. And the class interval you take 50, 60. Okay, the median class is 50 to 60. Now here, we know that this is the formula for this one. L is the lower limit in 50 to 60. 50 is the lower limit. And n divided by 2 is equal to 90. That means here already we got 90. And the cumulative frequency value of the preceding class interval is 75. See, this is the one. Very important. Preceding means before the one. Before this 105, 75. And the frequency of the median class is 30. Right. See, 75 just for CF value we are taking. Cumulative value of the preceding the median class we are taking. See, the other things, anyway, we got this cell. Like 105 we got. We will use 50 as the lower limit. We will use 60 as the higher limit. 30 the frequency. 105 is the cumulative frequency. Only in the CF we will take the previous value, that is 75. Now substitute this. N is 90. We already calculated n divided by 2 minus CF is 75. Frequency is 30. See, we are not taking the values which are related to the 75. We are taking the values related to the 105. Just keep that point in mind. Here you will be confused. Only 75 we are taking for the CF value. See, n divided by 2 and CF and divided by F. F again frequency we are taking 105 related thing, 30. Okay, into I, 10. Okay, the difference between the upper limit and the lower limit. Again, not 40 and 50. Of course, mostly the class will be the same, but we will be taking this one. 105 related this one, 60 minus 50, the 10. Now this is the median when the series is given. Okay. Right. This is inclusive series. We know that, this is a different series. This is exclusive series. What is exclusive series and inclusive series means? Exclusive series means other than 0 and 10, between 0 and 10. This is the thing. Here between 10 and 20. We are excluding those two things. Here including means including 0 and including 9. You will easily identify those series easily. They will mention this. When this series is given, again the solution will be the same. CF, lower limit, this one. Okay, right. This is another example. Compute the median from the following less than the cumulative series. Again, this is given. Now we need to conversion of the cumulative series into the exclusive series. Okay, 0 to 20, maybe less than 20, but 0 to 20, and this. And our remaining simple frequency is this for the 12, 24, and this. And the method is the same. Again, the formula, get this value, and you will get the value. Okay, the same answers. You can see those examples later. Now, how to determine the median graphically? We need to understand this. Okay. Just to see this, you will understand. See, we have this one, frequency less than cumulative frequency 3, more than cumulative frequency 0, more than cumulative frequency. Take these values and plot the graph. See, you will understand once you go through this, because we have a lot of things. I'm just going a bit fast. Already one model. Next one, median is done. Mathematical property and this. Other proportional averages. Next one, there are some bit illustrations are here. Based on the type of the question, you need to apply the formulas. Okay, for the discrete series and other things. Merits and demerits, you can read it. Now coming to the mode. What is mode? What is mode?
So number of times a particular item has been repeated.
Very good. If the value is occurring more times, which number is repeated more times will be the mode. Okay, the mode, there are different definitions here. You can read it, but simply mode is defined as the value that occurs most frequently in the statistical distribution. In French language, mode means fashion. FASHI. Okay, that you go through the definitions, you will understand. Average, first one, average the terms in ascending and different, arrange the items in the ascending and descending order. Okay. Next one, the value that occurs maximum times in the series as a mode. Which one value is occurring? The value of mode is generally denoted by check. Very simple for these numbers. Which one is repeated more? This is the in this solution variable 11, 12, 14, 16, 18, 20.
16 is the answer.
16 is the answer. Hence the maximum number of items. 11 is repeated twice. 12 is repeated 2 times, 14 is repeated 1, and this, and 16 is repeated 4 times. Therefore, the mode is not the 4, the value. See, we are observing this when even in the normal series, even in the median also, we are identifying this. That is the 12th item. 12 is not the answer. The number, the position, the number which is in that 12th position is the answer that we need to understand. Okay. This is a regular one. Discrete series. This is the frequency and how to calculate this discrete and continuous series. Inspection method and grouping table. Inspection method can be used to calculate mode in a certain situation where the sequence of the series is gradual rise or fall, whether it is increasing or decrease. The difference between the highest frequency and the next frequency, next highest frequency should be 4 or more than 4. This is very important. Let us say the frequency 3 is there, 9 is there. 9 minus 3, 6. 14 minus 9 is 4 is there, more than 4 is there. Then we can calculate. Highest frequency is 21. You know that this is 21. And its corresponding value is 10. Thus, the mode is 10. We know this directly by looking at this. This is calculated based on the inspection observational method. For example, the given series is 4, 6. This is. But sometimes it is not possible to look at the value of mode by using the inspection. Inspection means just by looking at it, we can understand. Say by looking at this, 10 number occurs 21 times. 21. The mode is the 10. Right? Which variable has 21 times 10? Answer. Okay, inspection method. In such case, you have to use the method name for the grouping method. If inspection method is not possible, how to do it? Frequencies are taken, frequencies are added in twos, leaving the first frequency and adding the next 2 frequency and so on. Frequencies are added in threes, leaving the first frequency and adding the next 3 frequencies and so on. See, next 2 frequencies want, next 3 frequencies and so on, leaving the first 2 frequencies and adding the next 3 frequencies and so on, like that analysis table. Let us say this is the one. Okay, how to group the table? 10, 20, 30, 40, 50 is there. And write down this, leave the first frequency and add the 2 thing, 20. And then the next frequency, leave the 2 first frequencies and add these 2. Leave the first one and add these 2. First one is we are adding this to 48. And next one for 56, add this 3. Right? 3 only, right? We are adding, yeah, 3. And it's done. And again for next frequency, for all the 56 plus, okay, leave the first one and add this 3. You'll get this 79. And leave the first 2 and add the remaining 3. This is 89. Okay, when you got like this, this is the analysis table. Wherever it is marked, wherever the empty table is there, you marked as the stars there. And the highest score in the analysis table is 5. This is the 5. And its corresponding value is 40. Hence, the mode is 40. Simple. Okay, if you just understand this, you will understand this. First one, frequencies are taken. Frequencies are added in twos. Okay, twos. Again, this two and this two and this two. Okay, the next line, leaving the first frequency, adding the next two frequencies, and so on. Leave this first one, add the next two frequencies. 48. This one, 36, 53. This one, 25. Yeah. Next one, third one, leaving the added in threes. Here added in threes. Leave the first frequency, adding the next three frequencies. Okay, for this, leaving the first one, next three. 12, 2, 6, 5, 73. Again, so on, leave the first frequency and next 4, 89. Like that, you need to go on this. And wherever the empty values are there, put the stars like this, ding, 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 stars. When more stars are there, you put 5. I mean, you calculate all these stars and you will get the mode continuous series. Okay, right? So the same answers, you can go and look at this analysis table. So this is about the mode. So generally the mode, we may not go for, in rare cases, we will get, in a different things actually. See, there are some formulas also. Mode is equal to 3 into median minus 2 mean. When median and mode are given and 3 frequencies are missing, okay, then we need to go for these different combinations of the formulas. Okay, just go through the different examples, you will understand that. This is all based on that. Graphically, in the histogram and mode, we can also draw these things, histograms, and based on the mode. Can also draw this merits and demerits of the mode. Interrelationship also, just go through the formulas. See, when sometimes they will give this is the mode and calculate the mean. Mean and mode are given, calculate the mean. We have these different formulas. We have this formula, and from this formula, we can derive a lot of many formulas. And based on that, they will give you this. Calculate the median and mode from the data given. Okay. And you can calculate mode. We know that. Which one is the frequencies? Median. Calculate the median, lower quartile and upper quartile, 6th decile and 21st percentile. Okay. Calculate based on using these other formulas. You will get these things. Okay. This is the summary. Let's, the basic things you understand and advanced things you try. Now, let us go into the variation and the skewness. This is very important to understand the next units. Okay. Variations, measures of variations and the skewness. Okay, let's try to understand, even though it is small unit, unless you understand these measures of dispersions and the variation and the skewness, the remaining regression analysis and other analysis we may not understand. Okay, please try to concentrate. The measure of the central tendency reflects the single numerical value describing the entire data, that we know that, but it cannot indicate the extent of variability in the distribution. That is, it cannot reveal the scatterness in the data. See, what is scatterness? When you take the average value, for example, how many are there in our class today? Including me, co-host and co-host, we have 9 people, right? Okay. Among the 9 people, I have taken the marks. Let us see who are there. We have Abraham, AK, Deepa, and Srinath, Sunita, and Vandana. No, people are there. I have gathered the marks from like quantitative analysis marks. Abraham is having 90. AK is having, who is AK? Hello? Is AK is there? Deepa? Are you all listening or just?
Yes, sir.
Nita? Yes, you're all listening, right? Huh. Skewness is, okay, people are not responding. Skewness talks about what we are not able to understand by calculating the average. Again, I'm repeating. Understand means we are calculating, it is the mean value is representing the whole other numbers, right? That is what we learn. Let us say Deepa is having 90 marks. Sunita is having 80 marks. Aviram is having 70 marks. And who else are there? Vandana is having 30 marks. Okay. And when I calculate the average, I'm not mentioning that Vandana is having a very less marks there. In order to understand the average, let us say average, I'm telling like 70. But Vandana is having 30. Is Vandana, am I able to see Vandana there? Whether she got less or high or this? No. And this skewness, how the average is fall representing the other people. Let us say average is 70, but Vandana is having 30. Okay. And how this is, what is that? How varied it is, and how less the other people get. In order to see the full graph on one person down, up, down, up, down, up. In order to see that, this skewness will be understood. Okay, let us try to see this. Dispersion is the measure of variation in the items. Please understand that we need to go for in a detailed way. If it is time taking also, try to understand. It cannot reveal the scatterness in the data. That's what we say. The measure of dispersion reveals the degree of scatter of values in a series from its average value. The measure of skewness is to determine whether a distribution is symmetrical or asymmetrical. Okay. This again, when we are talking about the skewness, what is symmetrical skewness and asymmetrical skewness? Okay, these things we need to understand. Now, this man Bowley gave a good definition, is the measure of the variation of the item. How one value is varied from another value, variation. Okay. The degree to which numerical data tend to spread about an average value, see this, is called the variation or the dispersion of the data. The measure of the scatterness of the mass of figures in a series about an average is called this. Okay, I think you understood that by looking at two definitions. The study of the dispersion of the grade practical should be practiced as could be well appreciated from the following example. See this? Series is this 130. This series is 360. This series also 60. Mean is 40, mean is 40, mean is 40. Okay. Now, since the arithmetic is the same in all series, but the three distribution different widely from one series with the other series. Hello? Are you all there? Yes, no? Yes? Yes, only Sunita is responding today. Yeah, okay. But see this. Average I'm telling is 40. But see, but here Sunita marks are 1. How far this number is away from this average? When I'm telling in this class, the average marks are 40. But Sunita got only 1 mark. Then how this 1 is related to the 40? Right. See, that is the thing. How it is distributed. See, a distribution of the value. See here, if you see this, everybody have 40 in the series here. Oh, that's good. Here, very less variation is there here. Right? 36, 37, this 40, it is all near to the 40. But here, see this. 1 far away from the 40. 4 far away from the 40. Even 10 also, 15 also. Even say 90. The person who got, let us say Sunita got 90 again marks. But sir, I got 90. How can you tell that this class average is 40? That's the problem here. In order to identify that, this dispersion, the skewness, all these things will be calculated. Let us try to understand this. One series with a series A, such an every item is perfectly represented by the arithmetic. That is, there is no dispersion in the series. Hello, are you understanding this? Is there any dispersion in that? Dispersion means, what is the another meaning for dispersion? What is the another meaning for dispersion? Excuse me, are you all there? Variation, okay? There is not much variation in that. Series B, only one item is perfectly represented by the arithmetic mean. The other items vary, but the variation is very small. C, single item is represented by the arithmetic mean, another value from 1. Series C dispersion is much greater compared to the B series. Now, for 4 basic purposes we record, right? The measure of dispersion points out whether the average of the series is represented as the distribution of determine the variability or not. Second thing, to serve a basis for control of the variability, the measure of dispersion serve as the controlling technique. Measures of variation enable to comparison to be made of 2 or more series with regard to their variability. The high degree of the variation would be the little uniformity or consistency, whereas the low degree of would be mean, great uniformity and consistency. Analytical tools like correlation analysis, regression analysis, and the analysis of the variation, testing of the hypothesis are based on the measures of dispersion. See, that's what I'm telling. The next unit are as completely based on this. We need to understand it very carefully. Properties of the good measure of dispersion. One thing, the measure of dispersion should be simple to understand, rigidly defined. Each and every item should be based on each and every item. It is further capable of algebraic treatment. It should not be unduly affected by the extreme values and having simply stability. Methods of studying variation. One is positional measures, and another one is one second. Yeah, sorry. Methods of studying variation. There are many measures for studying variation as shown below. One is positional measures, the range, the interquartile range and quartile deviation. Mathematical measures are the mean deviation and average deviation and the standard deviation. This is very important. And graphical method is Lorentz curve. This is one of the methods that they will use that. And absolute and relative measures of variation. This may be either absolute or relative measures. Absolute measures of dispersions are expressed in the same statistical unit in which the original data are given as rupees, kilo, studs. If in case 2 sets of data are expressed in 2 different units, and case absolute measure is not suitable. If they have given 2 sets of data, one is in rupees, one is in kilometers, we can't compare those 2 things and tell that this is the dispersion. Okay, measures of variation. Let us see that range. This is the basic thing, right? We know that the range, it is the simplest method of studying depression. Range is defined as the difference between the value of the highest item and the value of the lowest item of a distribution, symbolically L minus S. If this is the range, what is the highest number here?
360, sir.
Lowest number?
200.
160, right?
160, sir. Yes.
Yeah, and 360 minus 160 is 200. Okay, the relative measure of range of the coefficient is that L minus S divided by L plus S. This is, we will get the relative measure of the coefficient. This is the range. Okay, now if you take the value, average of these values, some value will come. Again, if that difference is more, please try to understand. This is, you can understand this clearly. If there's more difference is there in the range, because highest value is so high and lowest value is very low, like as we've seen in the first series 1 and 90, in the C table, then some kind of difference will be there. We cannot. Discrete series, frequency is the same absolute measure L minus S, last item is this is one, range is 1 minus 6,200. Relative measure of range is this. Okay, sorry. The coefficient rate. Absolute measure L minus S. L is then same. Range L minus S is equal to 70 minus 10 is equal to 60. Right. Largest item is 70. Smallest item is 10. 70 minus 10, 60. Relative measure of range. Coefficient of is this 0.75. To calculate the range either in discrete conditions, we have to consider only the variable and ignore the frequency. This is important. If it is individual series or discrete series, we need to take this. Why we are not considering frequency? Can anyone tell?
Frequency number of repetitions, but we have to calculate the range, so we have to consider the value instead of frequencies.
Yeah. Again, can you repeat?
Frequency is the number of repetitions it has occurred, sir. But to calculate the range, we need to take like whatever we have to be considered, like to calculate the as per the formula is like we do consider the value rather than frequency.
Okay.
In this point of view.
Your voice is breaking. Sunita, sorry, your voice is breaking.
So this
that's fine. Okay, I'll just clear it. Okay. See, we are not bothered whether 70 comes how many times and this, because we are taking the values, right? That is why I consider these values and directly attack this and you will get the answer. Now, if you take the continuous series, also will be the same, like almost like, but this is a relative measure of this and use of range, frequency, measure of range. Here we will take L minus S. Largest item is 700, lowest item is 100. See this 700 and the lowest item is 100 and range is L minus 600. Relative measure of range is 600. We are taking 100 and 700, but here we are not taking anything here. Directly we are taking range. Okay, merits interquartile range, quartile deviation. This is also we need to understand that how to calculate. Direct interquartile means Q3 minus Q1. Semi-quartile means Q3 minus Q1 divided by 2. Absolute measure semi-interquartile range Q3 minus Q1 divided by 2. Q3 minus Q1 divided by Q3 plus Q1. Okay, this is important. Individual series. Compute the interquartile range, quartile deviation, and coefficient of quartile deviation from the following. Here, Q1 is equal to 22.5. How we get it? The Q1, 22.5, interquartile range. And Q3 is equal to 633.5, the quartile deviation. And interquartile range is 63. So Q3 minus Q1 is equal to 45. Semi-quartile divided by 2, this you will get it. If you take the discrete series, you have to calculate the cumulative frequency. Q1 is equal to 30, Q3 is equal to 60, and interquartile range Q3 minus Q1 is equal to 30. Okay, and you apply the formulas, you will get that. Okay, when you know these quartiles, then you will understand that. Now, merits in this percentile quartile. Again, here, as already in the unit 7, we have discussed about this. Learned P10 is equal to 10, P90 is equal to 90, and and then calculated, and this percentile range is 90 minus 10, 80. Now let's go into the very important part, is the standard deviation. This is very important. This was given by Carl PSL. You need to remember his name in 1823. Everybody will use this standard deviation. It is more popular and wise measure of dispersion. Its signifies lies in the fact that It is free from those defects from which the earlier method suffer and satisfies most of the properties of the good measure of dispersion. See the range and the other quartiles calculation and all the things are, there are some things are there, but standard deviation is known as root mean square deviation. Root of the mean square deviation from the reason that is the square root of the mean of the quadral deviations from the arithmetic mean. Standard deviation is denoted by the Greek small Greek letter as sigma. You know that, right? Sigma. This is not completely printed. The greater the amount of dispersion, the greater the standard deviation. What is dispersion again? Hello? Simple words, simple meaning of dispersion. Variation, right? The greater the, yes, thank you, Sunita. The greater the variation, the greater the dispersion. Calculate the standard deviation in individual series. One is taken the actual mean and assumed mean. That by taking deviations of the items from the actual mean and deviation items from the assumed mean. Now, deviation taken from the actual mean is sigma is equal to square root of sigma x square divided by n, where x is equal to small capital X minus mean. Calculate the actual mean of the series. Take the deviations of the items from the mean, that is small x is equal to capital X minus mean, where small x denoted as deviation from the actual mean. Square these deviations and obtain value. Okay. Here, see this? Sigma. Actual mean of the series we will calculate. After that, take the deviation of the items from the mean, that is, you'll get the capital X mean minus mean, where small x denoted as deviation from actual mean. You will see that. So if you see one example, you will understand. Now, square these deviations and obtain the value of sigma x square. Divide sigma x square by the total number of observation, that is n.
Sum of all those
and
terms.
Yes, sigma means sum of all those terms. Thank you. And extract the square root. That just gives you the value, square root of this.
Summation.
If you see this, yeah, summation. If you see this, actually in Excel, I can tell you it's easy to get in Excel, but not the Excel. Excel in one click by applying that formula, directly you can get it actually. Okay, instead of you doing a lot of these things, but that is why we have different tools in the market in order to, calculate easily. And okay, let's do this. Compute the standard deviation and coefficient of standard deviation from the following data cube. What is coefficient of standard deviation? We have also learned that. See this? Again, let's go to the definition known as the root mean square deviation, for the reason that is square root of the mean of the squared deviations from the arithmetic mean. Okay, let's go into this. Now, this is the series. Mean we got as 24. The total is 24 to 40. And observations are 10, 24. Okay, that is the mean. Now, capital X mean is equal to 24. Capital X minus mean. We need to this X again, capital X, and we need to square this one. And what is this? Is my voice clear to you all?
So can you please repeat the second point?
Is the voice breaking? 1 second.
Yes, sir.
Oh, there is a problem with my internet. Yeah, it's too slow. Second. Is my voice clear now somehow? Same.
Yes, sir. No, it's fine.
It's fine, right? Screen also visible, right? Now, x square, we will get this.
Yes.
After getting this x minus means x square is equal to this square, you will get this square. And after that,
Sir, sorry
yes.
to interrupt you. Please repeat the second column part. So there was some disturbance, like we couldn't hear the second column part when you explained.
This one,
So X minus
this x,
that
okay,
area.
okay. Yeah,
Yes,
yeah,
sir.
okay, sure. See,
Yes, sir.
this is the values they have given 24, 26, 29, 25. This already we have written this as small x, it is denoted by x. And first calculate the mean value. How we calculate the mean? We know that summation divided by total number of variables, 240 divided by 10, 24. Till then it is clear,
Yes,
right?
Yes, sir.
Now,
Yes,
then this 24, we need to subtract this mean value from the actual value. That is, mean value is 24 minus 24, 0. 24 minus, small x minus mean, this one. This minus this mean value, 24 minus 24, 0, 26 minus 24, 2, and so on, 32 minus 24, 8, 20 minus 24 minus 4, and all these things. Calculate this. And if you calculate, you will get 0 here. Now, x square, you square this value again. 0 square, 0, 4. Now the d value, how will get this difference? X minus a into a is equal to 20. Where do we get the 20 here? Where is 20 here? But I got confused. Let's go into the formula. This is n, I think so.
I think assumed means assumed.
Correct. Assumed mean. Sorry. Thank you so much. Assumed mean. Assumed mean, how we will calculate the 4 plus 2, 6. 6 plus 5. Yeah. Here we need to take like this assumed mean. I'll take it as a 4 here. 4 plus 2, 6. And 6 plus 5, 9. And again, why I confused here, assumed mean. 1 second. They have given this assumed mean 24. Yeah. 4 x is 0. 0 minus 4 is 4. Directly they are calculating this capital X. Yeah. Okay. I think this will be given in the question actually. The assumed mean. They will given in the question and subtract this 24 minus assumed mean 20. 24 minus 24, 26 minus 26, and 29 minus a. This will be there. Actually, it will be given, come from the question. Okay, assumed mean also they will given. And once you calculate this, you square this d. D square is equal to 16, 36, 81, so on, you will get this. Now, this is the values that how you need to calculate. What is the final formula here? Explanation. Now, first one, calculate the actual mean, that is m is equal to 24. Already we got this 24 here. Right. Second one, take the deviations of the items from the mean, that is small x minus m, where x denoted deviation from the actual mean. That first we have taken. This is called the take the deviation items from the mean, small x minus mean. Square these deviations and obtain the total. This one. This you square them, you'll get this. And do summation of the squares, you will get this 356. And divide the summation by the total number of deviation, that is n. Extract the scores. Summation of x by small n is equal to root of this. And then the coefficient, then where x is equal to this, you will get this 356 divided by 10, 0.96, and you will get this value. Now, coefficient of standard deviation is equal to mean 5.97 divided by, this is the coefficient, this standard deviation divided by mean is equal to coefficient of standard deviation. Okay. Now, here, take the deviations of the items from the assumed mean. That is, D is equal to, yeah, we have this capital X minus assumed mean. Where, 1 second. It is, mic is towards me. Finally, we apply this formula in that, and you will get this standard deviation. Coefficient standard deviation, anyway, sigma divided by mean is equal to 0.25. Okay. Let me again repeat this quickly. See, this is very important sum. If they give you this, you need to solve in that way. Okay. And compute the standard deviation and the coefficient of standard deviation from the following. First, take these values, x values, sum them. When you get the sum, you know the mean, right? Calculating the mean, right? Sum of all these values divided by number of variables. 240 by 10, 24. It's clear. And after that, you subtract, find out the x again, capital X. How to calculate this? Small x minus mean. Mean already we have calculated. This value minus this value. We'll get this value. And square root these things. You know, first calculate the mean and subtract those values from the mean. Then you will get these values, square them, then you will get these values. Now find out the deviation. How you will get the deviation? Assumed mean, the capital X minus assumed mean. You calculate this, then you will get this value. See, this is X. This is the given value minus assumed mean. 24 minus assumed mean 20, you will get this value. And square them. See, you are calculating X, squaring them. Calculating D, squaring them. Again, to calculate the D, formula is X minus A. To calculating the X, formula is, let us the mean denoted by, generally we will denote the mean by, I think, small m or something, m. That's the mean should be subtracted from the main. The actual value will be subtracted from the mean. After you getting this, you substitute in this formula. Yeah. You will get the square root of summation of x square by n. Okay. X minus mean, where x is equal to x minus mean. You will get the value here divided by this. N, 10 is the number 10. Already we got the 356 here, x square divided by n. We got this value, and the mean is equal to standard deviation divided by mean is equal to this one, coefficient of this. Generally, deviations will be taken from the assumed mean. Okay, taken from the actual mean, this is the one, and if you take from the assumed mean, this is the formula. Okay, right. Discrete series methods, actual mean method, assumed mean method, step deviation method. Again, there are 3 types. These are the formulas. See, calculating is the same. Only you need to by heart the formula. There is no any other option for that. Right? Once you by heart the formula, you apply it, then you will get these values. This is the one. Step deviation method. This is the formula. Standard deviation from the formula. This is the thing. Again, for to calculate in the actual mean, we know that how to calculate the actual mean. Income is there. Number of person is this. Fx you need to calculate. Multiply this. Small x, because see, here they have given the formula. Go as per the formula. Whatever is required, you need to go into that. Fx, f into x, this one. X is equal to x minus mean, this one. And x square is f dot x square is equal to this. Because f dot x square, they ask us to calculate. Right? In the above formula. See in this one. Summation of x square. For the actual mean method. Divided by summation of f. You will get the summation of f here. Explanation, this is the summation of f divided by n, and you will get this value. Then the sigma is anyway, standard deviation is equal to root of this. Now tell me the formula of standard deviation for the normal thing. Leave about some advanced thing.
Square by n.
Square root of
Summation of x square divided by number of terms.
Very good. Square root of, right? Square root of summation of the x square divided by. Simply you will get the standard deviation. And the advanced thing, you just go through it, you will understand that. Computation of using assumed mean. See, formulas. Okay, it's not a tough thing. I'm not discouraging you, but here the thing is that I'm encouraging you to by heart at least few formulas. At least few formulas if you by heart it based on the questions, so that at least you can answer something there relevant to that particular question. Okay, there are some examples, good examples are given in your thing. Now let us go into the coefficient of the variable, standard deviation system. Very simple. Coefficient of variable CV is equal to, what is this sigma? Sigma denotes Sunita, you are speaking, but I'm not able to hear now.
Coefficient of variation, sir.
Sigma. Sigma means what? Sigma denotes what?
Coefficient of variation, sir.
Yeah.
No.
Standard deviation, Standard deviation denoted by sigma, right?
Sir.
Yeah, simple. Okay, right. Now, coefficient of variable. How to calculate this? Series A is there is B is there. Compute the mean and standard deviations of the series A. First series A. This is the class, this is the one, mid value, take it, fx 10 into this, you will get it. T1 is equal to x minus A by C. You will get the class interval, f d1, you will get this one, f into d1. Right? This one, A, series A into A, you will get these values. T square, you square these values. F dot d1 square, this one, f into d1 square, you will get these values. And apply in the formulas. Again, you need to by heart the formula. And see, it is all to find out the standard deviation. If you understand how to calculate, how to find out the standard deviation, then the remaining part you can easily, understand that. Okay. Yeah, maybe I will take some other examples in the tomorrow's class and we'll see the variance as well. Okay, we'll stop here.
So after lunch, will you take the class, sir? Actually, it has been like your slot has been reserved for after lunch.
Correct only. I think madam.
1:30 to 2:30, I think so.
Yes, madam. Okay, I'll just clarify that one once I'll talk to sir. Madam, I think the madam who's supposed to take that slot.
Can you please help us in assignment parts, sir?
What assignments you have?
Few questions are able to
Sunita,
since last week we started.
Sunita, I'm sorry. See, I don't know whether I have the network problem or you have the network problem, but I'm not able to hear your voice. Voice is still breaking. Is it same with everybody? Is my voice breaking or Sunita's voice is breaking? Hello, can someone respond who are in the group? Mahendra, you just unmuted and please tell.
Sir, you are clear, sir. You are clear, sir.
Acha, what Sunita is asking, can anyone tell?
Sir, small suggestion, sir.
Sir, in the
Yes,
assignment
ma'am.
part,
Sir, small suggestion.
Yes, Mahendra.
Sir, mostly important questions in the exam semester one exam, sir. In the subject, last end of the session.
Yeah. When I have the last session, ma, I think, do you have the timetable with you? Can you please just see and tell me?
so today is the date which they have mentioned in their timetable.
But actually, I think 1 week it is postponed, no? I think so.
I started listening to the classes from last week only, sir. Actually, I didn't get any information. They missed my number in the WhatsApp group. So I went to the university and I asked them, then they added me in the group.
Okay, okay. Amma, I think another faculty is joining now. Maybe in the tomorrow's class, in the before starting of my class, I will discuss these things. Okay. I will get some clarity from you, sir, as well. Okay. Please remind me before I start the class tomorrow. We'll discuss few things. Okay, right? Because at the end, other faculty has to join. No, that is why I'm not able to answer your questions. Maybe tomorrow, this first 5 minutes I will spend to clarify your questions. Okay, I'm leaving now. Okay, thank you. Tomorrow we'll meet.
Okay. Thank you, sir.
Right. I will get some